Work done in isothermal process. So in last video we found what is isothermal process and its indicator diagram and all that thing. So indicator diagram for isothermal process is this one, we know that. Now we can use this indicator diagram for finding the work done in the process. How to, let us see. We know that the small work done delta W will be equal to pressure into change in volume. This formula we all understood. So what I do here is, as the pressure and volume both are varying, I split this isotherm into infinitesimally small parts. And I consider a very small portion of this one. Okay. So very small portion of this one here. And for that particular portion, the volume change will be coming this much. There is a change of volume of delta V is coming. But as we consider the case of pressure, that pressure remains almost a constant for that small portion. So here I can take this in the form of what we call a rectangular strip here. Okay. For this rectangular strip, this can be taken as the pressure and this is the corresponding change in volume. Therefore, the small work done for that particular portion of the isotherm will be equal to that pressure into change in volume. But effectively that pressure into change in volume is nothing but equal to area of the strip. Area of the strip, let us say A, B, C, D. Area of the strip A, B, C, D. So like this, if I take another section here, another piece like this, I can divide this whole thing into small pieces like this and I will be finding the work done in each portion of the graph. I will be getting small work done delta W's there continuously, and in each case it comes as the what you call the area of the small strips for each, and as I move from V1 volume to V2 volume, for each strip the area I am getting as a small work done. And what is the total work done in this process if I take? I will be getting the sum of all these strip areas from V1 to V2. So if I add all that strip areas, effectively what I am getting is the area under the isothermal curve. So effectively I can say work done in isothermal process will be equal to the area under the indicator diagram for that process. It's a generalized form. So area under the indicator diagram gives the work done in the process. This is one way of finding the work done in isothermal process. But this method is not always possible. You need a graph and all those things to be drawn properly and to find out that. So if the values have very large variation and all, it is not possible to include that in the graph properly. Therefore, we will go mathematical in finding the work done in isothermal process. That let us see how it is. Now, I told you the integrate story, the small portion is taken and adding all that, we will be getting the whole thing here, the work done. So that process, if I take the infinitesimally small portion of that graph and adding all that infinitesimally small portion, that addition process is called integration. Therefore, the total work done in isothermal process can be equal to integral P into dV from V1 to V2, I could say. This is written for very small work done, that small portion. So when I add all that small portions there, infinitesimally small portions there, I will be doing actually the integration from V1 to V2, P into dV. But we know that P is not constant, it is also varying. Therefore, to remove that uncertainty, what we take here is, we have got the equation of state PV equal to K, therefore P equal to K by V I could get. So I am taking the pressure in terms of volume so that you can forget about that problem. So this can be written as integral V1 to V2 K by V into dV, I could say. So you can do the integration easily because volume is there with respect to changing volume. So here W will be equal to, I can write K constant outside, then integral V1 to V2, I get it as what? dV by V. So integral dV by V, according to the integration identity, we will be getting this equal to K into log V to the base E from V1 to V2. So this integral dV by V is the value is log V to the base E, Napier logarithm base. Okay. Now this can be written again as W equal to, if I apply the limits, K into log V2, the upper value to the base E, minus log V1, the lower value to the base E. Upper limit minus lower limit. And therefore W will be equal to K into log V2 by V1 to the base E. Because log A minus log B will be equal to log of A by B. There is that condition. So that condition I applied here, that I get it as log V2 by V1 to the base. Now this part is a problem here. What is K value? So to remove that K value, I am considering the equation of state again, so that equation of state, if I take as per the equation of state PV equal to K, but for a gas taken in a cylinder, PV equal to mu RT you can have, where mu is the number of moles taken. Okay. Therefore, the value of K is nothing but equal to mu RT. So that I can write the equation for work done, therefore will be equal to mu RT into log V2 by V1 to the base E. Okay. Again, there is a problem if you are using the log table and all. It is not easy to apply this log base E. The log table is base 10. So how to convert this base E into base 10? For that, there is a conversion factor that's equal to 2.303 into mu RT into log V2 by V1. So this is the final formula for finding the work done. Here log V2 by V1 to the base 10, that base 10 usually we don't write it, this is understood. So this is how we are finding the work done in isothermal process at a particular temperature T and for a particular number of moles of the gas taken. Understood this much? Okay. Now, one more point to be noted here is that as we have the equation of the gas PV equal to mu RT, we have two conditions, that initial case P1 V1 and final condition P2 V2. So as per this, what we get here is P1 V1 therefore will be equal to P2 V2, so that V2 by V1 will be equal to P1 by P2. So here, as we have got that expansion condition here, we have stated V2 by V1. That V2 by V1 can be substituted with what? P1 by P2, and therefore you can have one more formula here, that is W equal to 2.303 mu RT into log P1 by P2 in terms of pressure. So these are the equations you can have for work done in isothermal process. Okay? So please practice this one, how we are applying the mass in finding out the work done in isothermal process.